Okay, can you hear me at any of them? No? Okay, good. Okay, here we go. So looking back, we're going to take, it looks like implicit differentiation. Do I have y'all's attention over there? Yes? Okay, so looking at this, we've got, what variables do we have in the mix of our equation that we're looking at? And we got a y, right? Okay, by the way, there's a typo here. I got a few of them. I was very bummed. That's an x, by the way. So if you consider this curve, and we're going to take the derivative with regard to x. Can we do that still? Do we still remember how to do that? Once you've taken the derivative of each term, then we're going to move all our dyx's to one side and all of our non-dy dx's to the other side. Then we're going to get to factor it out, correct? And I probably wouldn't have shown all these steps, but that's okay. And then you're going to end up with dy dx equals 2x plus 5 over 3y squared plus 2. Do you agree? Everybody get the same thing? But, what if, oh, by the way, this is an x as well. How many other times do I have to write this down? What if they shift gears? What? Okay. What if they shift gears? Now we're not going to take the derivative with respect to x. We're going to take the derivative with respect to t.
I don't see a t here, so.
Isn't that awful? Okay. So now if I'm going to take the derivative with respect to t, it's just like doing the implicit. If I am not taking the derivative of the t, then I have to put it. For example, am I taking the derivative of a t value here? No? So then it's going to be 1. Do you agree? And then I took the derivative of y with respect to t. I'm so glad that y'all joined us. So then let's look at the next piece. Okay, if I take the derivative of this piece, 2x cubed, what do I get? Was there a t involved? So then I'm going to do a dx dt. And then I got this minus 4x, which is going to give me a minus 4. Is there a t?
Dx dt.
So dx dt. And then do I care about the 3? So then I could go on in this case, and I could simplify it by putting my dx dt outside.
Divide?
Nope, you just leave it just like that. Because more than likely some other information is going to pop up, and you're going to see that in just a second, okay? Based on that, y'all want to do another one together, or you think you're ready to run with it?
Let's try it.
You're going to try it? Okay. You're going to take this with respect to z. So remember, with respect to z. Do what? How to do what? Oh, the E with the stuff? So the E with the stuff will be 1, it'll stay just exactly the same. But then you also have to do this up here, right? So what would that be? 3E, 3Q, and then it was all the derivative of Q with respect to Z. No. Let's see. Can I pull all these DQs out?
Yeah.
I got what? 2Q minus cosine Q plus 3E to the 3Q. Oops, I don't need that. Are we okay with that? Does it matter if you put this here or if you put this here? No, it distributes just the same, doesn't it? Okay, you ready to try another? This one's going to be related to, with regard to T, right? We don't have any T's in it. Okay, when you get to right there, just stop for a second. Is everybody okay with that? Do you notice out here that they tell you dx dt? The derivative of x with regard to t is 4. Do we have a dx dt somewhere in there? So therefore, we can go ahead and replace dx dt with 4. Oh, that's minus line, sorry. Oh, can't write the right letters. So let's see, to continue over for there, could we do, did you already finish? Yeah. We would do what? Negative 8x. Do you agree?
Yep.
And then we could solve for dy dt. And we would get 8x over 3y squared. We okay with that one? Okay, you got another one in example 4. Once again, you're taking the derivative of y with respect to t. And you've got dx dt equals negative 3. And they want you to finish it to where your final answer will be dy dt. That would be the end. So make sure you understand when you're reading that question, why did I say we're finishing out with dy dt? you plug in dx dt? It equal -3. So we got -3 times 6x plus 4. And then we continue to simplify that. Probably have stuff we can cancel out, right? Have a wonderful day. We'll continue to work on this tomorrow.